compared to a similar map for the United States. As far as EV exports go, China has captured 40% of the market and is likely just getting started. At a major EV auto show in Shanghai, China's leading domestic EV maker, BYD, revealed their Seagull hatchback.
EV industry surges, one problem becomes even more apparent: battery prices. Batteries are the most expensive component of any EV, and so manufacturers have been searching for a cheaper, lighter, and more efficient battery.
1 ton of sodium costs only $150, but 1 ton of lithium is over $20,000. These batteries are an excellent substitute for lithium. Scientists are proposing a switch to sodium-ion batteries. So what is the difference between lithium-ion batteries and sodium-ion batteries? Lithium-ion batteries have dominated this industry for years. However, despite their usefulness in various contexts, they have significant limitations. The high cost of lithium, which is required in the production of lithium-ion batteries, is the primary disadvantage of these types of batteries. In addition, only relatively small quantities of lithium are dispersed across the planet. This increases the cost of transporting batteries from one location to another during the manufacturing process, which is detrimental to business and the environment. Sodium-ion batteries are one of the most recent rechargeable batteries to hit the market in recent years. Their research has been ongoing for decades before they were finally brought to the market. Because sodium is far less expensive and can be found in much greater quantities, the fact that lithium cannot be extracted in its elemental state also presents one of the primary challenges faced by lithium-ion battery producers. Before it can be used, it must be isolated from the other components. This procedure causes significant damage to the surrounding environment.
Today, more than ever, we're closer to that dream as the world's two largest battery manufacturers, CATL and BYD, have unveiled a game-changing sodium battery that has the potential to revolutionize the entire EV market. So what exactly is this new sodium battery, and when can we expect to see it in action? Join us as we take a look at this new sodium battery and when it's going into production. Before we go into the details, we need to understand some things about sodium batteries. When you take a glance at the periodic table, you might notice that sodium and lithium are neighbors, sharing similar physical and chemical properties. But did you know that sodium is over 1,000 times more abundant than lithium? Sodium is a key component of sodium chloride, or table salt, making it relatively easy to extract compared to the tedious process of mining lithium. Not only that, but the process of sourcing sodium is also more sustainable and environmentally friendly compared to mining lithium, which has significant impacts on the environment. Lithium mining in particular is notorious for releasing tons of carbon dioxide into the atmosphere, making it a major contributor to climate change. Moreover, the toxic chemicals used in lithium mining often contaminate the surrounding area, including our most precious resource, drinking water. It's clear that the environmental cost of mining lithium far outweighs its benefits. Another advantage of sodium over lithium is that sodium-ion batteries are easier to recycle and don't require rare earth elements that are associated with environmental problems.
Mining for lithium requires 500,000 gallons of water for each ton of the material, and the Lithium Triangle is a region that encompasses portions of Chile, Argentina, and Bolivia. Some of these locations are already highly arid and comprise deserts, making this a significant problem. The extraction of minerals in this area has used up more than half of the available water supply, devastatingly affecting the agricultural sector of the economy. The extraction of lithium is also not an environmentally friendly procedure. Lithium extraction has severe negative consequences on the surrounding ecosystem and the water it comes into contact with. Harmful compounds like hydrochloric acid can make their way into the water supply. Even in places like Australia and North America, where more conventional mining methods are utilized, it is challenging to dispose of and manage the chemicals produced by mining operations. Research has shown that mining operations in Nevada can affect fish populations up to 50 miles downstream from the actual mining activity. Mining for lithium results in contamination of the air, the land, and the water supply. There is also no benefit to recycling lithium batteries. Recycling lithium-ion batteries is one technique to help reduce some of the negative consequences that are caused by the mining of lithium. However, it is an inefficient process that consumes much energy. On top of that, recycling lithium-ion batteries is not a practical solution because sufficient research has been done on the topic. Some battery chemistries contain rare and toxic chemicals like cobalt, a metal mined in Central Africa, and have been highlighted as an example of conflict minerals due to human rights violations at mines from countries such as the Democratic Republic of the Congo, DRC. Earlier versions of potential competitors to lithium-ion batteries.
So the price of lithium hydroxide has gone up from a mere $6,800 per metric ton in 2019 to a staggering $80,000 per metric ton today. That's an increase of over 1,000% in just 2 years. Meanwhile, sodium hydroxide remains below $300 per metric ton. Clearly, sodium has a huge advantage when it comes to cost. However, it's worth noting that lithium-ion batteries are known for their high energy density and performance, which is why they're commonly used in performance and long-range Tesla models. But there's a significant problem with these batteries: thermal runaway. You may have seen news reports about electric vehicles suddenly catching fire or exploding. This is a serious safety issue that sodium-ion batteries do not have. Because of these reasons, CATL and BYD decided to develop a sodium-ion battery. In July 2021, CATL revealed its sodium-ion batteries, which possess an energy density of 160 kilowatt-hours per kilogram, a slightly lower value than LFP batteries. While their energy density of 160 kilowatt-hours per kilogram may not be the highest on the market, these batteries offer a host of benefits that make them a game changer. Not only are they more cost-effective to manufacture, but they also perform exceptionally well in low temperatures and boast enhanced safety features. Now, CATL has even more ambitious plans on the horizon, with their upcoming sodium-ion batteries set to exceed an impressive energy density of 200 watt-hours per kilogram. And if that weren't enough to get you excited, these batteries are slated to hit mass production by 2023, marking a significant step forward in the energy storage landscape. CATL's first-generation sodium-ion cells are already impressively affordable, costing just $77 per kilowatt-hour. And with the second generation set to enter volume production, that cost is expected to drop to an even more jaw-dropping $40 per kilowatt-hour. It's fascinating how quickly technology can evolve and change perceptions. In 2021, many experts believed that sodium-ion batteries were only sustainable for certain applications, such as energy storage and two-wheeled scooters. Even CATL held the same view. Some analysts even speculated that CATL's sodium-ion battery initiative was merely a ploy to pressure lithium suppliers to lower their prices. However, as the development of sodium-ion batteries progressed and lithium prices continued to soar in 2022, the tide began to turn. It became increasingly clear that sodium-ion batteries have the potential to become a viable alternative to lithium-ion batteries in electric vehicles. In November 2022, CATL officially confirmed this development, announcing that their sodium-ion batteries were expected to power electric vehicles in the future. Last December, BYD also announced their plans to commence mass production in 2023 and introduce a compact electric hatchback powered by a sodium-ion battery pack. And now, at the recent Shanghai Auto Show, CATL announced that their sodium-ion batteries will be installed in the Chery iCar, which is set to hit the market by the end of this year. Similarly, BYD has announced that their sodium-ion batteries will be in mass production by the second half of this year, starting with the Seagull. This announcement came just in time for BYD's unveiling of the Seagull at the Shanghai Auto Show. The Seagull comes in 3 different versions, each with varying pre-sale prices ranging from $11,450 to $14,000. While the current models are equipped with LFP batteries, the new versions will use BYD's innovative Blade batteries, which have capacities of 30.08 kilowatt-hours and 38.88 kilowatt-hours. The most exciting part is that these new models will be powered by sodium-ion batteries, which offer significant advantages over traditional lithium-ion batteries. While they have some advantages, such as improved safety and cost-effectiveness, they also have their limitations, particularly when it comes to energy density. As a result, more sodium-ion batteries would be needed to match the energy capacity of lithium-ion batteries, making them less suitable for use in electric vehicles. However, the lower energy density of sodium-ion batteries is less of an issue for grid-scale battery storage. In fact, utilities can simply install more sodium-ion batteries to make up for the lower energy density without the need for additional space. The Inflation Reduction Act passed by Congress in August 2022 was aimed at reducing China's dominance of the lithium-ion battery market. However, a shift towards sodium-ion batteries may actually increase China's control over battery manufacturing. Of the 20 sodium battery factories currently planned or under construction worldwide, a staggering 16 are located in China, according to consulting firm Benchmark Minerals. This means that in just a few short years, China will have almost 95% of the world's capacity to produce sodium batteries, although lithium battery production will still dwarf sodium battery output. But despite China's dominance in lithium production, it faces a unique challenge when it comes to manufacturing sodium batteries. While China controls much of the world's lithium sources, it has limited access to the soda ash required to produce sodium. Interestingly, the United States is home to over 90% of the world's readily mined reserves of soda ash. Located beneath the southwestern Wyoming desert, this vast deposit of soda ash was formed over 50 million years ago and has been mined for centuries to meet the needs of America's glass manufacturing industry. The question now is whether the United States will leverage this resource to become a major player in the emerging sodium-ion battery market. In the end, sodium-ion batteries present an exciting prospect for the future of electric vehicles thanks to their incredibly low cost compared to their lithium-ion counterparts. In fact, sodium costs only a fraction of what lithium does, a mere 2 to 3% to be precise. This means that we could be on the cusp of a revolution in the EV industry as these more affordable batteries pave the way for cheaper, more accessible electric cars.